Hi everyone, this video is going to demonstrate a way to analyze photos and pictures as high-dimensional datasets with VisuMap. Okay, the first thing we do is importing a picture into VisuMap. Here we first open the picture in VisuMap and then run a script that converts the picture into a high-dimensional dataset. We can see the converted datasets with the heat map servers of VisuMap. To start our analysis, we first create a 3D PCA map of the datasets. We can clearly recognize the sequential structure of the data. From the PCA view, we can select a section of the picture and see how the sections are mapped into the PCA map. From the heat map window, we can easily move the section by scrolling the mouse wheel. We can also create a PCA map for a selected subsection of the picture. Now let's use a more sophisticated algorithm to visualize our dataset. Here we use the TSNE algorithm to create a map. We see that the TSNE map has a simpler structure. It maps the picture sequentially from the top to the bottom. We can also easily create a TSNE map for a section of the picture. The corresponding map shows somewhat more details of the selected section. Let's now turn to a more complicated photo. We first import the photo into VisuMap. As we see, this takes a little while longer than importing the previous photo. Then we create a 2D TSNE map for the data. We see that the map also has a sequential structure, but it is more complicated than the previous one. And the sequential structure has been broken at several places. For better visualization, we configure TSNE algorithm to create 3D maps. We see that the 3D map preserves much better the sequential structure. At last, let's visualize our data in the 3D projective space with another mapping algorithm called the relational perspective map. The first run is somewhat too fast. Let's reduce the learning speed somewhat and repeat the training process. The result map this time is somewhat better than the previous quick one. A 3D projective RPM map is basically a dot plot confined within a ball. In order to explore such a RPM map, we use a special data view of VisuMap. This view allows us to rotate the RPM map in different ways within the 3D projective space. A key feature of the 3D projective space is that the opposite sides on the ball surface are actually stuck together, so that the data point moved out or rotated out from one direction come back from the opposite direction. We can see this clearly in this animation.